Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra right now. This is lesson 6.1 on the properties of exponents. Hopefully this is a review for a lot of you, but we want to make sure that we review this topic before we get into chapter 6 proper. So, our essential question: how can you write general rules involving the properties of exponents? Well, we're not going to answer that question so much as just go ahead and review the general rules for you. And first off, let's talk about the zero exponent. Essentially, the zero exponent says that for any non-zero number, that anything to the power of 0 equals 1. Okay? Anything to the power of 0 equals 1, except for, of course, 0 to the power of 0. So in words, in numbers, 4 to the power of 0 equals 1, or any variable to the power of 0 equals 1. For negative exponents, in words, a to the power of negative n is the reciprocal of a to the power of positive n. Okay, so that's the big idea here. So for example, 4 to the power of negative 2 is 1 over 4 to the power of positive 2. And the same for the variable. A to the power of negative n is 1 over a to the power of n. Okay, the reciprocal. Okay. So get those. You don't have to copy all of this into your notes, but again, these big ideas here are the ones that I'm trying to highlight for you. Let's take a look at a couple expressions here. First, we have 6.7 to the power of 0. Well, any number to the power of 0 is going to equal 1. So that one is just 1. For B here, negative 2 to the power of negative 4, well, that's going to equal 1 over negative 2 to the 4th power. And negative 2 to the 4th power would be negative 2 times negative 2 is 4. Let me write them all out here like this. We can keep track. There's a rule we need to talk about. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. And then negative 8 times negative 2 would be positive 16. Positive 16. So let's talk about this kind of rule here. If we have a negative base to a positive, to an even exponent, a negative base to an even exponent, it's going to be positive. Okay, so negative 2 times negative 2, that's negative 2 squared, that's 4. But negative 2 to the 3rd power would be 2 times 2 is 4 times negative 8. Okay, so an odd exponent gets us an even exponent, negative 2 to the power of 2 gets us a positive. Okay, so if we have a negative base, an even exponent gets us a positive answer. If we have a negative base, an odd exponent gets us a negative answer. Okay, so that's kind of a good thing to keep in mind here as well. Here we have a big expression, 4x to the 0 over y to the power of negative 3. And it says, write this using only positive exponents. Okay, well, what we can do here is we can think of the numerator as kind of the, let's say it this way. 4 is going to stay the same because there's no exponents affecting 4. X to the 0 is just 1. And then y to the power of negative 3, again, the reciprocal, so it's going to move from the denominator to the numerator. It's kind of like think of this part as this, 1 over y to the power of negative 3. So to simplify that, that's y to the power of 3 over 1, or just y to the 3rd power. So y to the 3rd power. So this is 4 times y to the 3rd power. Okay, so an easy way to think of this again is instead of thinking the reciprocal, just think that anything with a negative power is going to move from denominator to numerator or from numerator to denominator, and the exponent becomes positive. Okay, so that's that example. So be prepared to try and do some of those in class the next time we meet. We'll talk about product of powers here. Product of powers, to multiply powers with the same base. Okay, these rules apply for the same base. Add their exponents. The quotient of the property, quotient of powers properties, subtract their exponents. Okay, so these are kind of like backwards operations of each other. So for example, 4 to the power of 6 times 4 to the power of 3 is 4 to the power of 9. We add the exponents. For division, 4 to the power of 6 divided by 4 to the power of 3 is 4 to the power of 6 minus 3, or 4 to the third power. Okay, so we subtract the bottom exponent from the top exponent. Okay, that's kind of what you have to keep in mind. And sometimes you'll end up with negatives there, so you might have to simplify again. Power of a power property. This is when we raise a power to another power to find the power of a power, multiply the exponents. Okay. So that's when we have an expression like 4 to the 6th power, and we raise it to the third power. That's 4 to the power of 18. Okay. So kind of get this stuff into your notes. These are some general rules, and we will try some examples here. So here I have 3 to the power of 2 times 3 to the power of 6. They have the same base, so I can think of this as 3 to the power of 2 plus 6, or this is 3 to the 8th power, simplified. B says negative 4 to the power of 2 divided by negative 4 to the power of 7. Well, that's negative 4 to the power of 2 minus 7, which is negative 4 to the power of negative 5. Okay, but this isn't simplified yet because we now have a negative exponent. So this is 1 over negative 4 to the 5th power. And I'm going to kind of work sideways here. I'm not supposed to go equal like that, but and then this will be simplified as 1 over 1024. But remember, I have a negative base with an odd exponent, so this thing is going to be a negative, or the whole thing is negative. Okay, and then we have a power raised to a power. So z to the 4th raised to the power of negative 3. I think of that as z to the power of 4 times negative 3. I think of this as z to the power of negative 12, or 1 over z to the power of 12. That one's done. And this is a good example of why I say algebra is easier than regular math, because with the variables, I can just leave it like that. I'm not concerned if it's positive or negative. I just leave it. When we have this negative, when you do with real numbers here, I have to keep track of, when I simplify it, does it stay negative, or is it flipping back and forth from positive to negative, negative? Does it stay positive, or does it stay negative? Okay, so that's a good example of how algebra is actually easier than regular math. Power of a product property. So to find the power of a product, find the power of each factor and multiply. So when we talk about a product, we're talking about something like 3 times x cubed. That's a product, right? Because we're multiplying here. And then to find the power of this, we're raising it to another power. That's what we're talking about here. So basically the rule is find the power of each factor and multiply. Okay. So in numbers here, 3 times 2, you can think of this as 6 to the power of 5, or 3 times 2 to the power of 5. Well, that 5 applies to the 3, and the 5 applies to the 2. So it's 3 to the 5th times 2 to the 5th. And the same thing for quotients. You find the power of the numerator and the power of the denominator. Okay. So in this case here, the 3 divided by 2, all to the fifth power. I can think of this as 3 to the fifth divided by 2 to the fifth. Okay, in other words, the outside power applies to every factor inside the parentheses, and the same goes true here as well. Okay, for the um, product. Okay, for the product again, let me say one more time. The outside exponent applies to everything inside. Same for the quotient. Okay, so let's take a look here. Simplify each expression and write your answer using only positive exponents. Okay, so I have negative 1/5 squared and then y squared. I don't know if I just misspoke. That's negative 1.5 squared. So a negative squared would be a positive. So this is positive 2.25. And then y squared. For b, I would take a to the third power over negative 10 to the third power. So this is simplified to a to the third. Negative 10 to the third power would be negative 10 times negative 10 is 100. Times negative 10 again would be negative 1,000. For this quotient here, I think of this way. This is what I'm going to do here. So this is 3 to the fourth times d to the fourth all over 2 to the fourth. So that's going to simplify to 81 d to the fourth over 16. Okay. And d, and again, for all of these, just go one step at a time. 2 to the power of negative 5, x to the power of negative 5, and 3 to the power of negative 5. So I have all these negative exponents, which means what? They're all going to change places. So this is 3 to the fifth over 2 to the fifth, x to the fifth. And if you want to really simplify this all the way out, then 3 to the fifth becomes 27. I'm sorry, that's not right. 3 to the fifth becomes 81 times 3, 243. 2 to the fifth would be 16 times 2, 32. X to the fifth. Okay. And so those are all these examples. So we'll practice these in class next time. But make sure you kind of understand how I'm moving these exponents around and how I'm applying these exponents. And we'll skip that one and we'll do that one in class together. And that's it. Still a lot, but again, there's a lot in the introductory lessons of each of these chapters. Thanks a lot, and have a great rest of your day, and I'll see you next time. Bye-bye. Bye.